Hello everyone. Today we will see about logistic regression in machine learning. Let us consider the example. Suppose if you are asked to build a model to predict how many people can survey in the Titanic shipwrecking. We have to train the model with the passenger data sets such as their ID, their name, their siblings, their parents, ticket, fare, cabin, everything. Okay. So, and we have to drop the non-essential components of the data sets. Then we have to plot the graph. So from that we can identify how many can survive and how many people has the possibility of surviving to the most. So this logistic regression comes under the supervised learning, which means we have trained the data with a label. This comes under the classification. So logistic regression comes under the classification type of supervised learning. So it is able to predict the future outcomes based on the training from the past inputs. We can see some few classification models. The number is that decision tree. So here each node that represent a choice and a leaf node that represents the decision making. The second one is k nearest neighbor. Here based on the similarity of the objects we can predict the output. Third one is this logistic regression. Here we are having the data sets with one or more independent variables which helps to determine the binary value of the dependent variable. Suppose if you are having both dependent and independent variable, in the linear regression also we consider that the dependent variable is the crop yielding and the independent variable is the rainfall. So when you are having more number of independent variables, then it helps us to find the binary output of the dependent variable. So if you are buying a car, but we don't know when the car service is going to be next time, how long the car will work without any service. You can calculate the breakdown of a car based on its year. Okay. So in the x-axis we can plot the year since the car has the service, and in y-axis we can plot the probability of the breakdown in the car. Okay. So this is a regression model algorithm, helps to predict the binary outcome of a given set of many independent variables, and the dependent variable output is a discrete one. Now we can understand what do you mean by a logistic regression. Here the model can make the predictions. Axis that represents the probability value. The probability when it is less than 0.5 means, which means that the car will not get breakdown. When the probability is around 0.5 means it has the chance of getting breakdown in another 3.5 years. Probability value is greater than 0.5, which means that in this graph it is denoted as a discrete value of 0.9. Then the hair is having a high chance of breakdown. Linear regression normally helps to find the relationship between independent and dependent variable. Both are continuous terms. Here you can see a salary hike of an employee has been determined based on the rating of the employee. Here this is that regression line that has been drawn with the help of the slope equation y is equal to mx plus c. Compare this linear and the logistic regression type. So this is how the linear regression graph is, whether the employee get a promotion or not, whether it's a yes or no. Okay. So this is the rating, employee rating, and this is the probability of getting promotion. In the bottom, a line is drawn, and in the top of the graph, another one line is drawn. The bottom line that represents the probability of no, and top line with the probability of yes, which is a discrete value of 0 or 1. So this linear regression is a linear curve. From the graph we can understand that, but this curve is a sigmoid curve, and this has been determined with this green dot value. It can be changed from this curve to this curve. This curve is the logistic regression curve. This curve helps to determine the binary output value. So now we can find out what is the mathematical equation that is behind this logistic regression type. So now we can calculate the value of that theta. So that is a ratio of probability of that event happening to the probability of event not happening. If the probability of event that is going to be happening is represented as P, means this not happening is denoted as 1 minus P, because the total probability value is 1. So if the event is happen means it is represented as P, not happening means it is represented as 1 minus P. Actually, the value of this odd that ranges from 0 to infinity. Okay, but the probability value is ranging from 0 to 1. Take this equation of this straight line. Here this beta naught that represents the y-intercept, and b1 that represents the slope of the line, and that x represents the value of the x coordinate, and y represents the prediction value. So that equation is represented by y equal to beta naught plus beta 1 into x. This is that equation of that sigmoid function, 1 divided by 1 plus e to the power of minus that y value. So that y is beta naught plus beta 1 into x. This is how a sigmoid curve is obtained. How both are different from each other. So linear regression normally helps to solve the regression problems. Here this logistics helps to solve the classification problems. It is continuous in nature, the variables are, but in logistic it is categorical in nature. When compared to that linear type, here it is based on specific categories. Whenever there is a change in the independent variable, we have to estimate the value of the depending variable again. The logistic regression helps to calculate the possibility of a particular event that's going to happen. Linear regression is always a straight line. It is normally a sigmoid curve, which is denoted as a S curve. In application of this logistic regression is a weather prediction. We can't able to predict the weather accurately normally, but this logistic regression helps to identify the weather clearly. Okay, so we can predict whether it is a sunny day or cloudy day, or if there is a possibility for rainfall or not. Everything we can able to predict it. Image categorization and classification also, it must be more useful. If a particular picture is taken which combines both humans, animals and vehicles, it can help to categorize into various segments. Humans as separate, animals as separate, and vehicles as separate. In medical applications also it must be useful. For example, based on the injury severity and the age and the previous trauma, we can determine the survival rate of a patient. Now we can see that with a case example. Now we are going to predict the number that present in that image. This is a training set and this is the test set. We have to divide the whole data first into training and testing. Now we have to train the model. So after train the model, we have to apply the test images and it identify what is the number that present in the image. Now we are going to implement them with the Python. So we have to import the libraries initially. Then we have to determine the total number of images and labels that are present, because as we already mentioned, it is a supervised learning method. So we have to label the input data. We have to display some of the images and labels that is present. To divide the whole data sets into training and testing data sets, we have to separate them. After separating the training and testing data sets, we have to import the required logistic regression model to predict the output of the first element of the current test data set. Now we predict that the output of the first 10 elements of the data sets in an array. The entire data set is predicted. Now we determine the accuracy of the model. So after determining the accuracy, we have to represent in a confusion matrix in a heat map. How we represented that? Here the accuracy score is obtained as 0.94202. Now here this is how we can accurately predicting the image contain a 0, and sometimes a error will be occur, that is inaccurately we can predicting the image to contain a value of 7. So these are all the predicted labels. So this is the predicted and the actual values of the images. Finally, it is correctly identified. I hope everyone understand the difference between logistic regression and linear regression. Meet you in the next video. Till then, it's goodbye from Vijay.